So for nitrogen, starting with its electron configuration, nitrogen is atomic number 7. It's right here in 2p3. 1, 2, 3. So our electron configuration is going to go 1s2, 2s2, 2p3. Perfect. So 2p can hold 6 electrons, but for nitrogen, 2p is not full. We stop at 2p3. Just so that you can kind of see the whole picture of where this is coming from. 1s, and then we just read straight across. And then after 1s, we go to 2s, say how many total electrons are there, and then after 2s, we go to 2p. The number of valence electrons that nitrogen has, remember we're looking at our outermost s and p sublevels. So for nitrogen, my highest energy level is energy level 2, and I have both S and P in energy level 2, so I'm adding all of those electrons to count towards your valence electrons. So 2 electrons in 2s and 3 electrons in 2p gives me how many valence electrons? 5. And then this will match when we do our Bohr model as well. So 5 valence electrons. Nitrogen, like we said a second ago, has 7 protons, and there are also 7 electrons when it is a neutral atom. When it's neutral, it's not stable because it doesn't have a full valence shell. We can tell because when I look at 5 electrons, that's not full for any of the energy levels. So when I draw my Bohr model, I'm starting with 7 protons in my nucleus. Again, there would be some neutrons in the nucleus, but we're just skipping that because we don't have a mass number. And it's not relevant here. Our first energy level would have how many electrons? 2. Second energy level would have how many electrons? 5. 1, 2, 3, 4, 5. I know it's kind of getting messy and they're overlapping. So 5 electrons are in my second energy level, and that's it. There's nothing after that. So that is my valence shell. That is what goes along with the number that we counted from our S and P sublevels. If you have 5 valence electrons and the goal is to have 8 to become stable, the options that we have are either gain 3 electrons, or we could get rid of all 5 of those electrons and drop down to the lower energy level that's already full. The atom is always going to do whatever is moving the least number of electrons. So in this case, losing electrons doesn't make sense because I would have to lose 5. So instead, I'm going to actually gain how many? If I have 5 and need 8, 3. And if we gain 3 electrons, if I look back at how many protons and electrons I had to begin with, if I started with 7 electrons and then I gain 3, how many electrons do I now have? 10. So if I think of this in terms of which one is outnumbering the other, are my positives outnumbering my negatives, or are the negatives outnumbering the positives? Negative is winning, which means that I'm going to have an overall negative charge. The previous 2 examples each had positive 1s. But here, it's more than just 1. It's actually outnumbering it by 3, which means that I have a negative 3 charge. So my symbol would be N with a minus 3 charge. The other way that you can write this is N3 minus. But if you just put the negative symbol, that implies that it's a 1, and that's not true for this. So if it's a 3, you have to include the number 3. So the only reason that we could just get away with putting a plus for both lithium and sodium is because the number associated with it was 1. Does that make sense? Cool. What really throws students off is that we are gaining electrons. So you're adding electrons to this atom, but then your overall charge is negative. So you have to remember that what you're adding is a negative thing, and that's why it ends up becoming more negative. And then finally, our last example is sulfur. Sulfur is atomic number 16, and it sits in 3p4. So we need to go through all of the electrons in its electron configuration before we get to 3p4. So we start with 1s. 1s will have 2 electrons. After 1s, we go to 2s, 2, then 2p, 6, and then 3s, 2, and 3p4. If I'm looking at my valence electrons, don't forget that this is your S and your P sublevels and the highest energy level. So for sulfur, my highest energy level is energy level 3. Energy level 3 has both an S and a P sublevel, so I would add those together. So 2 plus 4 gives me how many valence electrons? 6. Sulfur, like we said a second ago, has 16 protons and 16 electrons if it's a neutral atom. So my 16 protons in my nucleus, again, they would have some kind of neutrons as well, but we're not concerned with those. And then we'll place our 16 electrons on the different energy levels or orbitals. So 2 in energy level 1. Energy level 2 would be completely full with 8 electrons. And then energy level 3 is almost full. It has 6 electrons. And so with 6 valence electrons, if your goal is to have 8, our choices are either we can lose all 6 of those and drop down to a lower energy level, or we can gain 2. So which one are we going to do? Gain 2. If we gain 2 electrons, that means we had 16 and now we'll have 18 electrons. So my negatives outnumber my positives by 2. So my symbol would be S with a minus 2. Or you could write it S2 minus. Again, since there's an actual number and it's not 1, we do need to include the number with it.